MPSG's on-farm network has been investigating foliar fungicide applications with interested farmers since 2017. We'll review results from those trials today. But before getting into the trials, I'd like to provide some context and background on different pea diseases that are infecting our crops here in Manitoba and what diseases we're managing with fungicide applications. Mycosphaerella blight, it's also called Ascochyta blight, that's our main disease target of fungicides, so we'll look at its life cycle in a bit more detail here. It's overwintering on soil, on crop residues, and on infected seed. And then in early summer, these airborne ascospores, they're released, and they might travel long distances by wind to infect pea crops. Initial infections commonly appear as these small dark freckles in the lower canopy near the soil surface, or you might have these ring lesions appearing kind of in the mid canopy. Those are typically moving in a little bit later, but most often those early symptoms we're seeing are these freckles on the lower leaves. Then over summer, these lesions will expand, and then secondary infections by rain splash and humidity, that'll move that infection up the crop canopy. And then after harvest, pea residue, soil, and seed can carry this disease life cycle on. So fungicides, they're applied around flowering when we just have these initial infection symptoms popping up, and that's to limit disease spread up the canopy. While Mycosphaerella is the main disease target, there are other diseases infecting peas. So Mycosphaerella blight and bacterial blight, they can commonly be confused in the field. They'll look pretty similar. This can be pretty troubling since bacterial blight, being a bacterial disease, it will not be controlled by fungicides. So at fungicide timing around flowering, what we're scouting for in peas are these small dark freckles on the lower leaves. Since this disease is coming up from the soil and crop residues, we're looking at those leaves nearest the soil surface in the bottom of the canopy. Bacterial blight, on the other hand, is infecting following leaf damage from storms or heavy rains, so we more often find this disease in the mid to upper canopy. These leaf lesions are typically more angular. They're following leaf veins instead of crossing them, giving them this really angular, sharp appearance. The edges of these lesions will initially look pretty water-soaked, kind of darker around the edges. And then later on, they'll progress into these larger lesions. They might have this kind of window pane type appearance that you'll see. And that's kind of how to tell those two apart a bit more. Less frequent foliar diseases that we'll see in peas are downy mildew and white mold. With downy mildew, the top of the leaf, you'll have these pale green spots. And then when you flip that leaf over, you might find these kind of fuzzy gray fungal growths on the bottom side of the leaf. For white mold, very similar to other broadleaf crops, you'll find pale, wilted patches of the crop with these hard black sclerotia bodies on the stems. White mold isn't as prevalent in peas as it is with other broadleaf crops, just since there's generally less leaf material with our semi-leafless pea varieties that we're commonly growing right now. Annually, pea fields are surveyed for diseases in Manitoba, and in addition to those four foliar diseases that we just talked about, we'll also commonly see Fusarium root rots and Aphanomyces root rots in this survey. In terms of how common are these diseases in Manitoba, here are the average percent of pea fields infected with these diseases over the last 3 years. So we do find some level of Mycosphaerella infection in every pea field every year. Those disease spores are carried by wind over long distances, so we do see some level of infection every year. It's the timing of that infection that's quite important. For bacterial blight, we've seen just over half of fields infected on average, and then a third of fields infected with downy mildew on average, and just 6% of fields infected with white mold. For the root rots, we do find some level of Fusarium root rot infection in every field every year as well. And we've also been seeing some higher levels of Aphanomyces root rot in peas over the last 3 years, present in 93% of fields on average. So you can learn more about Aphanomyces root rot and Fusarium root rot in the video on MPSG's channel titled Aphanomyces root rot, if you want to learn more about those root rot diseases. They will not be controlled by these foliar fungicide applications we're going to talk about. Within those infected fields, how severe was the infection? So for Mycosphaerella blight, on average, it was a 3 on a scale of 0 to 9. So that means that up to 50% of the lower canopy was infected, and up to 20% of the mid canopy also had lesions as well on average. So kind of a moderate to low level infection on average. For bacterial blight and downy mildew, on average 0.3% of the leaf area was infected, so pretty low, and 0.1% for white mold. So foliar diseases that are controlled by a fungicide include Mycosphaerella, downy mildew, and white mold. And you can see from the severity and frequency of these diseases that it's really Mycosphaerella blight that we're targeting with our fungicide applications. So with that introduction, let's talk about on-farm trials comparing fungicide strategies. So we have two trial types, the first comparing a single application of fungicide at flowering versus none, and the second comparing a single app to two apps. So we'll talk about these two a bit separately. It has been more common in drier years for farmers to be comparing a single versus none, asking that question, do I need a fungicide application in a dry year? And then in wetter years, it's been a bit more common to compare single versus double application, asking the question, do I need that second application to protect and maintain pea yield? First, we'll start with the single versus none trials. So here we're looking to evaluate the impacts of a single application versus none in peas. Will a fungicide application reduce Mycosphaerella blight disease pressure? Will it improve yield and provide a return on investment? So from 2017 to 2022, there have been 25 trials across the province comparing single versus none. They're in this map on the right. Fungicide product choice throughout these trials is up to the farmer, and those fungicides are applied according to label recommendations. Of these trials, fungicide applications were made at R1 to R2, which is typically early to full flower, and on average, that fell at around July 3rd, anywhere from June 26th to July 22nd, though. Big range. Products used are in this table on the right. Most commonly, the most common products tested were Diax, followed by Cotegra and Delero. And then average pea seeding rates across these trials was 350,000 seeds per acre, and the average established plant stands were 238,000 plants per acre, or 5.5 plants per square foot. And then all of these trials were grown on 10 inches or narrower rows. Here's the percent normal rainfall for these trials, the single versus none trials, leading up to flowering in June and following application in July. So each of these paired bars represents an individual trial, with the lighter colored bar on the left representing June moisture and the right darker colored bar of the pair representing July moisture. And what we're showing here is that June rainfall was normal or above normal at 9 trials, and July rainfall was equal or greater than normal at 13 trials, or half of these trials had more moisture in July. Starting in 2019, disease pressure was evaluated in every strip of the fungicide trials. Incidence and severity ratings are taken for Mycosphaerella blight, both for foliar infections and stem infections, and white mold as well. Downy mildew and rust presence, they're noted, but not rated as intensely as for Mycosphaerella and white mold. Starting with the Mycosphaerella blight foliar infections, for each trial we have incidence, or the percent of plants infected. That's what this graph on the left is showing. And the severity of the infection is the graph on the right. For each of these paired bars is each representing a trial. The lighter color on the left, those are peas that had no application, so untreated peas. And then the darker colored bar on the right was peas with a single application of that foliar fungicide. So what were we seeing in terms of Mycosphaerella blight foliar infections? A single application of fungicide significantly reduced the amount of plants with foliar symptoms at just one trial, reducing disease incidence, or the percent of plants infected, by 22%. And then the severity of infection was reduced at 6 trials with a fungicide application. So an average disease severity of 2 here, that means there was mild to moderate disease symptoms on the lower third of the plant. Fungicide applications limited the spread of disease further up the plant canopy at these significant trials. Stem infections were rated separately, and that's what we're showing here for each trial, with again the percent of plants infected, or the incidence, on the left, and the severity of that infection on the right. Stem infections overall were less common than foliar infections. Stem infections of Mycosphaerella blight were also most common to see in 2020. So a fungicide application reduced the percent of plants with stem infections at 2 trials in 2020, and severity of stem infections were also significantly reduced at 4 trials in 2020. So here, an average severity of 2, that means that Mycosphaerella stem lesions were restricted to the lower third of the plant, just towards the bottom. And in terms of white mold, 7 trials had some white mold present, occurring in 2019, 2021, and 2022, with just 3 trials where the percent of plants, where more than 10% of plants were infected with white mold. So with a fungicide application, white mold incidence was cut in half at this trial in 2022, and severity of the infection was also significantly decreased at that trial. At all of these other trials where white mold was found, it was really just present at trace levels. There's not a lot of infection, even though we had some showing up on plants here and there. Looking at yield results for single versus none. So again, each of these paired bars is representing a trial, and the number above the pair, that is the yield difference between no fungicide on the left and a single application on the right. So how much was yield changed with that application of fungicide? So a single application of fungicide applied at flowering, that significantly improved pea yield 28% of the time, on average improving yield by 4.6 bushels per acre when significant. So interestingly, in 2020, when we saw the greatest amount of Mycosphaerella blight in these trials, we don't see that significantly translating to yield here. So in 2017 and 2018, we don't actually have disease rating data available to investigate those yield results a bit further. And at these trials in 2019 and 2022, we didn't see any change in Mycosphaerella blight or white mold disease pressure to explain those yield differences there. At this first trial in 2019, the severity of Mycosphaerella blight was reduced with a fungicide application. And in 2022, this large 12.5 bushel per acre increase was at the trial where white mold incidence and severity were cut in half with a single application of fungicide. So we're seeing a really large yield response there, likely due to that big change in white mold disease pressure. So at these significant sites, did an application of fungicide pay for itself? Were the yield increases large enough to cover the cost of that fungicide product? If we assume a fungicide cost of just over $20 an acre and a pea sale price of $10 a bushel, a yield improvement of more than 2.1 bushels per acre is needed to improve profitability, and that happened at 5 of these trials. So this means that 20% of the time, a single fungicide application provided an economical yield increase in peas. So in summary, comparing one app to none in peas, we did see a yield response 28% of the time, on average improving yield by just under 5 bushels an acre, and 20% of the time that yield response was economical. Fungicides are not a one-size-fits-all game, so return on investment is really going to come down to how early plants are infected with Mycosphaerella and if growing conditions are conducive for disease to develop up the plant canopy. So we will talk more about making fungicide decisions after we talk about the next trial type comparing a double versus single app. The second fungicide trial type is comparing 2 applications of fungicide versus 1, also called a double versus single app. The questions we're looking to answer are, will a second application reduce disease pressure? Will it provide a return on investment as well as improving yield? So from 2017 to 2022, 16 trials have compared 2 applications of fungicide versus 1 app in peas. And the distribution of this trial type is here on this map. So these trials were more common in fields that had persistent leaf wetness and more moisture in the growing season. In terms of application timing, the first app was generally applied at early to full flower, which occurred on anywhere from June 20th to July 12th. The second application was applied at R3 during flat pod stages 10 to 14 days later. 75% of these trials rotated chemistries for their second application. Products included Cotegra, Delero, Diax, Headline, Lance, Priaxor, or Zolera. And then on average, across these double versus single trials, average seeding rate was just shy of 380,000 seeds per acre, and living plant stands were on average 274,000 plants per acre, or 6.3 plants per square foot on average. So here's the percent normal rainfall for June and July at each individual trial. June and July rainfall were normal to above normal at 4 trials each, not at the same 4. but a third of the time, or third of all of these trials, we had a bit more moisture in both July and June. Disease ratings were the same as described earlier. We're evaluating Mycosphaerella blight and white mold while making note of downy mildew or rust disease pressure. We're rating both the incidence, or the percent of plants infected, as well as the severity. And these disease ratings are just available from 2019 onwards. So starting with Mycosphaerella foliar infections, with incidence on the left and severity on the right graph, the percent of plants with foliar infections of Mycosphaerella blight didn't change with a second application of fungicide, but the severity of infection was reduced at 2 trials significantly. And then in terms of stem infections, a second application of fungicide did reduce the percent of plants with stem infections at 2 trials, and the severity of infection at one of those 2 trials. White mold was present at 3 trials occurring in 2019 and 2022. Incidence and severity were not significantly different between 1 and 2 applications. No changes here significantly. And that takes us to the yield results from these 16 single versus double trials. So a second foliar fungicide application improved pea yield 44% of the time, improving yield by 5.1 bushels per acre on average. So we are seeing a more frequent yield response than we saw with single versus none trials, and we're also seeing a bit bigger yield response on average to that second application of fungicide. We don't have disease rating data available for 2017 or 2018 to further explore those yield differences, and there's also no disease rating data for this one significant trial in 2022. At this trial in 2020, though, a second application of fungicide reduced the severity of both foliar and stem infections of Mycosphaerella and had a big impact on reducing the percent of plants with stem infections by 40% on average. At this trial in 2022, a second application reduced the severity of foliar infections, restricting disease to those lower leaves. And then at these last 2 significant trials, there was no change in Mycosphaerella blight or white mold disease pressure between 1 and 2 apps to explain that yield difference. And did that second application pay for itself? Was it economical? So where significant, a second application of fungicide provided a return of investment of anywhere from $5 to $50 an acre. So every significant yield response here was large enough to cover the cost of the fungicide using those same assumptions as earlier. So in summary, a second application of fungicide in peas improved yield 44% of the time, and it was the economical decision in those fields. So how can we determine when we're most likely to see a yield response to those fungicide applications in our pea fields? And that we start by scouting. We scout around early flower, typically from the middle of June to the end of July. And what we're looking for is at the bottom of that crop canopy, these freckling symptoms of Mycosphaerella blight. For a second application, we're again scouting it from anywhere from bloom to full pod stages, assessing that disease progression. Is it moving up the plant canopy? Because we want to keep it restricted to the kind of the lower part of the plant as to not limit yield. And when we're scouting, we do use a scorecard for making spray decision. It walks through different risk factors like canopy thickness, humidity, forecasted conditions, and symptoms on pea plants. So if those all add up and you're above a 65, the recommendation is to apply a fungicide. It's really helpful in making those decisions. And this is pretty handy because it can also be used for both first and second application decisions. You can also reach a 65 without having severe disease symptoms, but it's likely that if you have a 65 with all of these other factors adding up, disease is likely going to be developing soon. So visit more areas of the field or come back in a couple of days to reassess and revisit this scorecard. So you can find this on our website at manitobapulse.ca, or you can search MPSG pea fungicide worksheet. Along with the scorecard, this fact sheet does have a little bit more about information, some reminder photos for what do these diseases look like and how to tell them apart, and what do they mean in terms of pea yield. So it can be a pretty handy resource to have on hand. As for other management strategies for Mycosphaerella blight, start by making informed foliar or fungicide application decisions using that worksheet. And a 4-year break between pea crops is standard to manage and minimize Mycosphaerella blight disease loads in a field. Some variety resistance is available, so choose varieties with at least fair disease resistance ratings. Be sure to plant disease-free seed when seeding. And you do have the option to consider tillage to bury crop residue following harvest if the disease was quite high. But do remember that this disease is airborne, so it will still blow in from neighboring fields. That's not a complete solution. And then intercropping might be an option to minimize disease pressure in peas, but it does still currently need more research. In summary, Mycosphaerella blight, that's our main foliar disease of concern. Early infections are much more troublesome and concerning. So we're looking for those small freckles in the lower canopy, and we're aiming to prevent them from moving up the plant. So we're scouting around flowering and early potting to determine if those fungicide applications might be necessary, really leaning on that decision worksheet. So if you're interested in seeing individual trial results, they're all available in the On-Farm Network results database, which can be found at manitobapulse.ca or by following this QR code here. And if you're interested in participating in a trial or hosting a trial, contact Ian, the On-Farm Network technical specialist. His contact information is right here. And thanks for your time today. I've been Laura, MPSG's Western agronomist. You can stay up to date on research results like these by following us on social media or by visiting us at manitobapulse.ca.